So there are three basic properties of logarithms that we need to know, and we can use these to evaluate a logarithm or to solve an equation, but anytime you want to use these properties, the first thing you have to make sure of is that the bases are the same. So I see here I have log base b and log base b, and it's going to stay log base b. So your base is always going to be the same. The first two properties are very similar to each other. If I have multiplication happening inside of my argument, I can split that argument into two separate logs that I'm going to add together. Same if I have division, only instead of adding them, now I'm going to subtract those arguments. So if I wanted to rewrite letter A here, I would rewrite it as log base 4 of 5 plus log base 4 of x. So I've just split my argument, since it's being multiplied, into two separate logs. Notice the bases stay the same, and we're going to add them. Now with the second one, I'm dividing, so I can split that into natural log of 8 minus natural log of x. Again, the bases stay the same, and remember natural log means log base e, and I'm just going to subtract those two logs. Now the last one here involves exponents. If you have an exponent on your argument, I can bring that exponent out front and make it a coefficient. So I can rewrite this letter C here as 2 times log base 6 of 7. So anytime you have a coefficient out front, you can make that an exponent on your argument, or if you have an exponent on the argument, you can bring it out front to be a coefficient. So these next few slides are just going to be practicing those properties. So the first one here is to expand. So I'm going to take this one logarithm and I'm going to expand it into a bunch of logarithms. And I should have no multiplication, division, or exponents when I'm finished. So the first thing I'm going to do here is I see I have a numerator and a denominator. So I'm going to use my second property that we talked about, and I'm going to subtract them. So I'll have log of 5x squared minus log of y cubed z. Now notice I didn't write base 10 there. Remember, if it's base 10, then it's just implied. You don't have to write it. If you do write it, you're not wrong, but you don't need it there. So now I cannot bring this 2 out front just yet because that 2 is only on the x, it's not on the 5. If this was in parentheses, then I could, but since it's not, I can't. So now I'm going to split this because it's multiplication here. So I'll have log of 5 plus log of x squared, and I'm going to split this log as well, but since I'm subtracting the whole log, I'm going to keep it in parentheses so I remember that I'm subtracting the whole thing. Now I can bring those exponents out front. So this first one will stay log of 5 plus 2 log of x minus 3 log of y, and I'm going to distribute that negative, so I'll have minus log of z. And that's it. Now in my arguments I have no multiplication, division, or exponents. For my second one here, I'm going to do the same thing. So again, I see we have division here in my argument, so I can rewrite this as natural log of the square root of 6x minus 7 minus natural log of 9. Now, the root we know is really an exponent, so that's really 6x minus 7 to the 1/2 minus natural log of 9. So I'm going to bring that out front. And that's really all I can do. If you go back and look at the properties, inside my argument here, I have addition or subtraction. If you have addition or subtraction happening in your argument, you can't change it. There's no property that's going to allow you to change it. So do not change this into natural log of 6 minus natural log of 7. That is not what the properties say. So I'm actually finished. Now, if we were in class, I would ask you to do the next two on your own. So if you want to pause the video and go ahead and try those two on your own, you can. So this first one, let's see. So here are your answers to these two. Now if you did this first one out of order a little bit, that's okay. Like if you said that this was x to the 1/3 over y to the 1/3, then you wrote natural log of x to the 1/3 minus natural log of y to the 1/3, and then you brought the 1/3 out front and got this answer, that's fine. As long as you're getting this answer at the end, you're good. Okay? So if you have any questions on how to do either of those, you can just ask. Now, condensing down into one logarithm, you're going to do a lot more than the expanding. This condensing we're going to use a lot when we're solving equations. So before I can condense these two together using my property, I have to get rid of this 2 out front. So I'm going to rewrite it as x plus 2 squared minus natural log of x. And now that I have nothing out front, I can use my property. So this subtraction means I can rewrite into one logarithm, and I'll divide my arguments. Now, a big mistake that students will make on a test, and I'm going to write no, so we remember not to do this. Do not say that this equals natural log of x plus 2 squared divided by natural log of x. The properties tell us that if you're subtracting 2 logs, you can write that as 1 log and divide the arguments. The property does not say that you can magically just turn subtraction into division and say this minus this is the same as this divided by this, which is not true. Okay, so make sure you are not doing that on your test. The second one here, okay, again, I have to get rid of my coefficients first. So this would be log of 3 squared minus log of x plus 1 to the 1/2. And again, I didn't write the base 10 because I don't need to, but if you did, you're not wrong. And we have log of 9 minus log of 1/2 means the square root. And now since I'm subtracting, I can write this as 1 log and divide my arguments. So again, for the next 2, if we were in class, I would ask you to do these on your own. So if you want to pause the video and go ahead and try them on your own. So here are your answers for these 2. Now with the right one, I'm sure some of you didn't know what to do with that 2. The entire log is being divided by 2, so I just brought that out front as a 1/2. 1/2 times log base 2 of x. And then we make them exponents. And I wanted to show you both answers here. The first answer is if I added the exponents, because I know if we would multiply x to the 1/2 times x to the 5th, you add exponents. I just wanted to show you that just in case this was a whole number. Like let's say this was 2 instead of a half. Then your answer would be x to the 7th because I'm going to add my exponents. Or if you wanted to, I know this is the square root of x, so if you wrote it like the second one here, x to the 5th times square root of x, then that's okay too. But, oops, just know that these 2 answers are the same. So if this ever happened to be a multiple choice question, you should know that both of these answers are meaning the same thing. So now the last thing we're going to do here is evaluate these without a calculator. Now, we had done these before in class without a calculator, but we were always able to figure out each log individually. So 8, this one we would ask 8 to the what power equals 2? Well, we can't do that. 8 to, I don't know what power equals 2. So instead, we're going to use our properties. So I see they both have the same base, so that means I can multiply the arguments. So this is going to be 64. Now, what exponent does 8 need to equal 64? Well, that's 2. Okay? Same thing over here on the right. So now, since it's subtracting, I'm going to divide. So 75 divided by 3 is 25. And again, what exponent does 5 need to equal 25? Well, that also happens to be 2. Now, I would expect you to be able to do this without a calculator. So 112 divided by 7, if you can't do that in your head, you're going to have to use long division. And I'll do the long division here just to give you a little refresher. So 7 goes into 11 one time. You'll subtract, bring down the 2. 7 goes into 42 6 times, and you're left without a remainder. So this is going to be log base 4 of 16, and again your answer is 2. I promise you they're not always 2. Now over here I'm going to multiply, so 2/3 times 3/2 is going to be 1. Now what exponent does 7 need to equal 1? Well, that's 0. So for these last two, again, if we were in class, I would ask you to do them by yourself. So why don't you go ahead and pause the video and give them a shot. So there are your answers for these two. So for the first one, you're multiplying all three together, and you can multiply 2 together first, like 3 times 6 is 18, and then take 18 times 8. That's fine. But you should be able to figure that out without a calculator. And then again, that answer is 2. And then the second one here, you multiply first. So we multiply 500 times 4 to get 2,000. And then we're going to divide by 2 since we're subtracting. And remember, since the base isn't written here, that means it's base 10. So what exponent does 10 need to get to 1,000? Well, that's 3. Okay. Your homework's there at the bottom of the page. It's just more practicing, expanding, and condensing. If you have any questions about anything, please don't hesitate to ask.